pressures are already set. So you don't monkey around with the secondary valves here. These are on pretty much where they need to be. You get the instrument to start, I'll let you push the magic button really hard. It says power.
Got it.
Right now, you typically put the lamp that we're using right next to this, the calcium lamp. So this is currently designed to set up to look at just calcium. And we've got a whole box load of lamps here with that. A lot of lamps. So we have lamps just about everywhere. It takes it a while to come up. So a couple of small details. This is an old lamp. You can tell because there's a little adapter here. That's used so that I can actually look. I can put current in using the old style plugs, but with a new style adapter that fits into the instrument itself. So this adapter is very important. We use that. We can't use half the lamps. Most of our lamps are old. We have a few new ones that use this style of fitting directly, but most of them aren't. Let me see if I can find that. So this is the new style lamp. Notice how it doesn't have that long skinny thing coming out of it. It has just this fits directly into the thing, so you don't have to play with the adapter.
So like the little prongs that go right there.
Actually, I'm going to change this out to show you how it works.
Okay.
Because right now it's with calcium. Okay. Before this thing gets all warmed up, we also have to turn the hood on because you're going to make a flame, and I want to make sure the exhaust goes up and out. So that's all the way.
Go again.
I think you can use your finger, but it's always used to do so easy. So you say, okay. And then you've got a couple of things you can control here. I'm going to set up the instrument. That means I'm going to get this lamp to tune up, so you'll hear it start to tune to maximize the signals. So the instrument gets to here, do its thing, and click, 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 click. Do it? I can't hear it. It's not doing it. Come on, do it. Okay, maybe they wonder if somebody took the lamp out in between. Okay, they can turn the lamp off. Okay, now it's going to tune up. You have to turn the lamp on. Sometimes they can turn it off and they shut down and stuff like that. What it's doing is it's maximizing the signal through the instrument. You'll learn this next week. This is a double beam instrument, just like our unit is, but the reference side doesn't have a sample. It just has all the rest of the optical pathway. So that seems to be happy. Should be bigger than that, shouldn't it? How would it work with calcium? That's wrong. What's this guy doing? Where's the wavelength? Okay. Huh. Just know that it's got calcium in there. I'm going to select something's amiss here. I don't know how he managed to do that. Okay. So sometimes you got to see it's all filled out.
Okay.
And for some reason he managed to blank it out. He's been playing with it. He's learning how to use it. Okay, so now I'm going to set it up again because this should wander back and forth. There it goes. So you have a choice of wavelengths here. I'm just going to pick 422. When we get together and talk about this instrument in more detail, I'm going to pick for you a region based on the sensitivity that I want to use. And so this is okay for now. Now you can hear it. Now it's tuning. So when it's all grayed out, it's thinking, and when it comes back, it's done. What it's doing is it's adjusting the optics to maximize the signal after further multiplier tube. Okay, it's all done. Now the fun part. Let's turn on the flame. draining a lot. It's pinched somewhere.
Oh no.
It also means that there's another issue here. There's a little loop in here. It has to be filled with water, which is actually a problem. So you can get waste goes. It's actually you burn stuff and you're sucking up solution as it goes, and most of it gets thrown away. It gets thrown in here. You do that on this. And this loop should be all filled. So I want to make sure it's nice and filled. Fill it up there. Put it all back together. This could take 20 minutes to fix. He knows all about it. All started with this. Let's try it. Yay! Okay, now we're done. Now you get to do this. This is fun. This is the equivalent of the on button for the flame. Which places? You get to click.
Oh, I just have to click it. Oh, that was. Look at that.
Is that cool? Okay, so turning it on makes you have to make sure that when you're turning this turn on, you're seeing a particular element. The wavelength you selected, and these are the suggested split list that you're supposed to use. That's not automatic. There's actually a library in here that contains all the various parameters. So if you go to Tools, you can look at recommended conditions for calcium. There are only two wavelengths you can use. The sensitivity here is about the range that you can expect to get down to. This is milligrams per liter, which is parts per million. This is kind of not too good. 430 parts per million, that's too high. We're typically looking at 3 or 4 parts per million. So the lower the number, the more sensitive it is. So we picked the 422 number.
Yeah.
So when you go through and you actually set the instrument up, you go to the recommended conditions, you'll select. And all that stuff is loaded in. The old days, it's currently there is a book. Okay, so we want to do some analysis here. Typically what you need to do is get yourself a solution which is a blank. It uses up a lot of sample fast. You can see why just a bit. You sample your sample through this little filter. This is a capillary tube. Now, take a look at the color of the flame right now. It's kind of a nice, it's not gray. It should be bluer than that. But Scott's been monkeying around with calcium, so we've got a lot of calcium inside the flame. But as soon as I put this in, you're going to see it turn on. That's your background.
Oh, I'm so happy I got the AAS.
I know.
Okay, so now we're going to analyze the blank. I forgot something. You need to go to parameters next. You have to decide how you're going to take the signal. Okay, so this is saying I'm going to look for 3 seconds. That's the integration time. I don't like 3 seconds. I like 1. 1 second. Okay. Replicates, how many times you're going to do this over and over. Typically, I think 5. All of them.
Does the number of replicates like matter for like?
It's going to average over the 5. The more you average,
The better.
But then there's an issue of time because 5 seconds not the equation is a second.
Mm-hmm.
There's a delay time, that you're going to have right after that.
So if we had a higher amount of replicates, would that just mean more sample would have to be used?
Yeah.
Okay.
Exactly. So that's something you should do. And the lead delay is between the next. When you make another measurement, there's going to be a delay. I usually put 1 second.
Good idea. She's videotaping.
Yeah.
Oh yeah. this modern generation has a lot of advantage breeding. I didn't even get to use those in my day. Okay, so we're all set to go. Now we're going to run. So I'm going to analyze the blank. This is, I forgot the 0, huh? Oh, you're forgetting how shit works. Okay, just to form the auto 0. That's what it is. It's zeroing out the blank. I'm going to take a look again just to make sure the number's 0. So you just do it again. Okay. should say point to zero. Get it close to zero. So typically you might need to do this a few times. Kind of clears through it. So you're kind of zero, let's do it again. So while it's doing that, I'll get a sample.
Yeah.
Sample, just take this out, put it in there.
Oh.
For a while, and then you hit analyze sample. So the average is 0.525. You write that number down.
Oh, okay.
That's pretty much all you need to do. So if you're a series of samples, you're going to look at 2 kinds of signals, calcium, or copper, and nickel. So you're going to have to change lengths. So I'm going to show you how to change the length. You can keep running this as you do it. We'll take this out as I don't use it all the time. Let me show you something. You're going to leave it on. It's the hardest part of the instrument from the startup is getting the flame to start. And almost always the problem is in what's called the inner one. That's easy. So here's what I'm going to start with. I'm going to shut the lamp off now. Okay, I forgot what to turn off. I haven't used this in a year or so. No, actually, I probably made a small mistake. I should have gotten the flame started first before I did this because it's changed things. So start the flame and then do it. I haven't done this in a year, so I forgot what I'm doing. When it turned off, go to install lamp, I want to turn the lamp off. And if I were to show you what happens is the light window goes off. The little red light stops glowing. Okay? And I can take this off. Take it out like I'm put it here. You really slide the whole thing off. Try not to handle the front face of this. It's got a full space of light. You do this, you get some green hands all over it. It's away. And we're going to install the nickel one.
That's a nickel one, yeah. Now, do you have to have like the certain element lamp for whatever you're scanning?
Yeah, we have about 35 different elements.
So if you didn't know what was in the sample, would you not be able to use the AAS?
Yeah, you should know what you have ahead of time. This presupposes you know what you're doing.
Okay.
Since you've actually made up your samples and you're trading what it is, that's in the problem.
So now for like the lab when we're using like the copper nickel solution, will we have to do both a nickel lamp and a copper lamp?
The copper lamp has the old-fashioned thing that looks like this, so you're going to have to adapt it. This one is the new-fashioned one, so this one just slides directly in. So see how that, so you can see what goes right in there. Like that. Oh, it went on. Yeah. It's supposed to go on.
Oh, now it's off.
No. That's curved, that's the case. Okay, now we got to install the lamp. So you hit that little thing that says elements and select the elements. Nickel. Okay, I'm going to turn it on, but I'm going to pick a wavelength first. So to do that, I'm going to go to Tools and look at recommended positions for you. We're typically going to be sort of in this range, 8 ppm. So I'm going to pick this one.
341.
341. So I'm going to pick the 341. So now I will set up the instrument at that particular wavelength. And it's picking. Slide of burner dirty. A good clean flame is what's called clean blue. Is that what blue means?
No.
Dirty inside.
Yeah.
Now, what would you have to like take it apart, clean the inside?
That's what it's saying. The good thing about the instrument is it zeroes out whatever was in there, so you just zero over it. But a good operator would make that clean all the time. if you only use this once a year, I get these.
Yeah.
It's getting a little. We put some calcium. Calcium is notorious for building up. Not great yet. Okay, all set up. Let's run it back now. Is that the calcium or the
That was the calcium. No, that
No, I think
we should. Yep,
That's
that's
the-
the
So let's go to the
reference. Yeah.
make sure we're going to use the same settings for the analysis. So it's 1 second for each measurement, 5 replicates, and a second between each sequential measurement. So we're going to analyze the blank again. Same old, same old. So it's really pretty simple. Just now, the actual working of the instrument, the optical calculator, we're going to go to the next week. That's a little more involved. So now it's a little bit off, so we're going to zero it again. New lamp, so let's get used to it. And I'm almost there. I want to
Yeah.
fraction. Yeah, I don't know if I've got to make the signal, but you can see how it will go. If I
Yeah.
just stick it in there, we measure
Yeah.
it. You can, in principle, print everything out. I don't like the computer. Not here. I don't like the computer interface with this thing, so I write everything down. So you'll be measuring your samples, writing down your services on average, and it'll take literally 20 minutes to make the measurements.
So you don't have to like wipe this off, you know what I mean, before you put it in different samples. Just
You let it clear it slowly a little bit. That's how you get multiple measurements. So you suck it up and
Okay.
purge the system of the previous sample. So you do it a couple times. You see how quickly I've drained that down. Okay, so any questions about this? It's pretty much all you need.
yeah.
Now let's shut it down. Start with the lamp. All lamps off. Flame. Flame. Okay, now what I'm going to do is turn the gas off. I'm going to bleed the gases into the lines. You leave out and shut this off first, then you hit bleed. Just
Oh,
put
okay.
gases in the line.
Yeah.
So would you want to make sure you turn these off first, otherwise it
It'll suck it all out.
Yeah.
This is the second most explosive gas in the universe.
Perfect.
Yeah. Good.
Be careful. Okay, we're set. So it's really hard to turn it off.
Um,